Hello guys, welcome to Ask Raghulan. Today we're going to see another interesting topic in the science playlist. So this is going to be about tethering from Earth for space transportation and also for space tourism and for even for other man-made missions. So what is this tethering? So what is the concept of tethering and why this is in use these days? So now the space exploration has gone into the next step where there are private companies who's taking interest into space exploration, and there is a lot of companies which rely on sending packages to space and getting resources back from space, sort of a lot of samples. So now this is a sort of like an age where space exploration will go to the next stage and everyone will start competing in this space. So now in this case, so the current technology that we use, the rocket technologies, are very expensive, unreliable, and so it's not very quick to send something back into space and getting things back from there. So now in this scenario, the tethering has been a concept which people have been talking theoretically for a while. So now people started doing some experiments on it. So let's get to it and see what it is. So tethering is basically connecting a string from Earth, and actually it's elongated beyond the stationary level of the Earth, that is beyond the gravitational pull from the Earth, and then it is supported by a counterweight. And now this cable will be stretching literally around 22,000 miles, which is around 35,000 kilometers, which is pretty far from the crust of the Earth. And this cable will also support a transportation module. So this could be called as a climber. So this actually climbs from the surface of the Earth to the end of the tether, and from here there will be sort of like a docking station. From here there will be a launch vehicle which will actually take it to, let's say, Mars or International Space Station or to the lunar surface. So this is the concept people have been proposing for some time. So now the things have moved little far now. The things people have done little about this one. Let's look into it. So in the near future, so there is few companies and few governments which are very keen to put this in practice. So the first one is NASA. They have got some paid funded studies into this one, but they don't have any plans on building something like these. So the second one is JAXA, which is the Japanese astronomy, just similar to NASA. So they have plans in 2045 to build a tether, and that would connect Earth and probably to the outer space. So that is their program. And China has got a similar plan, but they got somewhere around 2050. So I think this the Chinese version, I think they may go a little earlier, 2045, and the Japanese version might be around 2050. So that's the planned schedule. This is not yet concretely confirmed to 100%. So the next one is the Lifeport. It's a private agency as well. So they have done a lot of miniature version of these tethers, and so they have said that their missions have been successful, even though they had faced little issues during those missions. But they are pretty aggressive on their research. They even gone a bit further on researching on the type of materials, and they have got quite a few patents on this one. And then if you look at the current technology that we have, the typical rocket system that we have, which we propel using solid and liquid fuel propellant. So the rocket comes with a launch vehicle, and then the payload sits on the top, and then the boosters. So long ago, so we've been using these boosters, which is generally get destroyed after a launch. They have to build another one. The inventor of SpaceX, they have actually started using these booster rockets, reusable booster rockets, which pretty much once it actually crosses a certain elevation, the booster rocket separates from the main launch vehicle, and then they actually come back and land safely into the docking stations, so they can reuse it. So now that actually reduces the cost. So that's one of the reasons SpaceX is one of the they won few contracts with NASA to send some payloads to space. So now if you look at it, even with the current technology, we're looking around $20,000 per kg of payload. So typically if you're sending payloads, let's say of a ton, you multiply it by the 1,000. So it's actually pretty darn expensive. And then the next thing is, if you see how this entire tethering concept works, let's get to it a bit deeper. So first thing is we will have an anchor to the surface of the Earth, and this would be probably on the equator. The reason we put this on the equator is because we generally send things to moon. So moon would be a sort of like a next colonizing space. So we will start building base up there. So the equator will be the apt choice because it's right next to the moon. And so if you look at the distance between Earth and Moon, you're looking somewhere around 38,000 kilometers, 38,000 kilometers from, 380,000 kilometers from Earth. So that's pretty long way. So the tether is not going to reach the moon. So it will actually cross the stationary level, and so the docking station goes up here beyond the stationary level. So the distance that we're planning to build the tether is around 22,000 miles, which is around 35,000 kilometers. And so then the tether will be sort of like a special materials. So people have been researching different materials. There is a whole bunch of other candidates as well. So the current eligible candidates that we have, people are rooting it for is Kevlar and carbon nanotubes and Dyneema. So if you look at all these three, Kevlar has been proved as one of the toughest material that we have used. It's got both carbon and which is called the anti-corrosive elements as well. At the same time, it is pretty strong, multiple times stronger than steel, and so it's used for bulletproof vest. So it's a very strong material. We have tested and we have used it. And the second one is carbon nanotubes. The carbon nanotubes are a research material. It's a new material, and so they are literally around 100 times stronger than steel, and they are literally the strongest, and people wanted to use this material because it's carbon, so it's actually anti-corrosive, and it tend to survive a lot of different conditions as well, and it's very strong. And the only problem with that one is the quantity of how much we can produce that element. So this is a rare material, so it's not going to be available in large amounts. And then Dyneema, it's actually a polyethylene plastic, so we can produce this in quantities, but the problem is they are not going to be good against radiation. So the problem we're talking about is when this tether crosses a certain point, the Earth's surface, which is having the ozone layer, which is protect us from the UV rays, is not going to be protecting the tether anymore. So it's away from the UV rays protection, so it's gonna have to face the sun's UV rays, and so it needs to have such sort of properties which it can sustain for a longer period of time. So now if you look at it, the typical challenges that we would face in this project is, first is the material for the tether. So that is one of the biggest challenges, because we need to have this material in large quantities to support the project in a long sustainable way. And also if you look at it, this structure will be one of the biggest man-made structure ever that's built. So it's going to be a pretty large structure as well. And then the quantity of material that we need should be of large quantities, and we should be able to produce it quickly, and we should be able to manufacture, fabricate much quicker. So next one is the withstand corrosion is one of the biggest things, because there is different types of corrosions that could take place. So because most of these anchors, people expecting it to be on a floating surface, so like a ocean or a sea or some place where it can float, so that even if it is actually moving a little bit due to any of these other anomalies, it should be able to work easily out. So so when it is on an ocean or a sea, there is going to be salt vapors as well, so which it needs to withstand. And the other one is atomic oxygen. So when these tethers are actually connected outside with the counterweight, when the Earth is spinning quite fast, so there is going to be molecules which will be bombarding these tethers at high speeds. So these atomic oxygen molecules, when they actually penetrate to these materials, they start becoming corrosive, and these materials tend to corrode. So that is one thing they need to withstand as well, which is going to be a bigger challenge. And then next one is meteorites. So meteorites, it's a common phenomenon that we generally get quite a few meteorites in a year. So if this tether is hit by a meteorite, it shouldn't break away. So it should be strong enough to protect itself from most of the objects. And then UV rays. So since it's going to be away from the protection of the ozone layer, so the UV rays is going to be something which the tether will be exposed to. So it needs to have some protection against the UV rays. And then the temperature shifts, since it's actually coming from the ground crust of the earth, and then it's traveling outside. So there is going to be really different temperature variations that we would have to sustain. So from a warmer weather to the coldest one. So those are the things. And then another concept people have also been proposing is actually the lunar tether. So the advantage of the lunar tether is pretty much, you connect the same sort of tether. Instead of coming from Earth, it actually comes from lunar. So with the our Earth tether, we are actually using the centrifugal force to actually use the counterweight and the centrifugal force to keep the tether in a place. So now the problem with that is Earth has got a very, very strong gravitational pull compared to Moon, and the advantage is Moon doesn't have an atmosphere, so we don't have to worry about corrosion from half of those elements. So now when you actually stick something from the Moon to a certain distance where it actually can reach to a common point from where we can use that as a transportation to the lunar surface, it will be great, because it will actually make it a lot easier to do soft landings on Moon, which is one of the biggest challenges for most of the Moon landing missions. So even the last mission India has Chandrayaan-2, which has failed because of the landing. So this would actually save the cost of landing onto the Moon surface. Now, if you look at it, either it's from Earth or from lunar surface, so most of these tethers will tend to reduce the cost of transportation to space between the current cost. We know it's around $20,000 per kg. It will actually going to reduce it between $100 to $1,000 per kg, which is like around just 5% of the current cost, which is a really huge savings. So now if that could be possible, and how much is the cost of the total project we're expecting? So a Japanese agency has estimated that this could cost between $1 billion to $90 billion. That's actually a huge range if you look at it. The whole point is, so there is a whole bunch of unknown factors that's out there. So that could be the reason that the cost might go higher, because we may have some failed projects, and there is a learning curve in there as well. And now, if you look at it, what are the advantages? Why do we need to get to this space, and why do we need to invest on this? The main thing is, first thing is, there is going to be a huge influx to space tourism, because it's going to be safe, and it's going to be faster, and it's going to be economical as well. So there is going to be a huge boom in space tourism. So there is going to be a lot more companies jumping onto the space, and a lot more businesses will be investing on this one. And the second thing is resources. So we will not be able to sustain ourselves with the current resources that's available in our planet. So we will actually exploit almost all of these resources, and we would run out of resources. So similar to what's happening with oil at the moment. And so now with this tethering in place, we should be able to extract lots of resources from Moon, and not just from Moon, from Mars. Asteroids could be one of those biggest things that we can do. Asteroids are treasure troves. They come with lots and lots of gold, lots of diamonds, and you can imagine lots of materials that we can actually use it for further space exploration as well. So with this tethering, we should be able to export, import, and build bases. You can do a lot more with these ones. And space travel will be cheaper, of course, and there will be more safer space travel, and it will be lot more reliable and quick. And some of the other things is why people are looking for more easier space access is because if you are able to find water in Moon, Mars, doesn't matter where it is, water is made up of H2O, hydrogen and oxygen. If we are able to get water, we can actually make fuel out of it, and from there we can start exploring further parts of the space. So that's all for today, guys, and hope you like it. If you like it, subscribe to the channel and share the videos. Thank you.